So I want to do another example of an implicit differentiation type problem. And this one is implicit differentiation in disguise, sort of. So what we're going to do is we're going to find the derivative of arcsine of x. And remember, arcsine is the inverse function to sine. So the way we're going to do this is we're going to let y be equal to arcsine of x. Right, so y is arcsine of x. And what we want to do is we want to find y prime. Right? We want to find the derivative of arcsine, and so we want to find dy over dx. Well, we don't know how to do it if it's arcsine, right? We don't know how to handle arcsine. But we've talked a lot about what to do if it's sine. And so since sine is the inverse of arcsine, we can take the sine of both sides of this, and that'll get rid of the arcsine for us. Right? So if we take the sine of both sides, the left-hand side is going to be the sine of y. The right-hand side is the sine of the arcsine of x. Right? And sine of arcsine, well, they undo each other, and so we just have x. Well, what we have now is that x is equal to sine y, and now we can take the derivative of both sides of this thing using implicit differentiation. All right, so if we hit both sides with a derivative, the right-hand side is the easier of the two. The derivative of x with respect to x is just 1. All right, so what we're going to have here, on the right-hand side, we're going to have 1. On the left-hand side, we have the derivative of sine of y. And here we're thinking of y, again, as a function of x. And so we have something more complicated than just x inside of sine, and so this is the chain rule. Right, so what we have is the derivative of the inside, which is y prime, which is the thing we're really after. And the derivative of the outside function, well, here the outside function is sine, so its derivative is going to be cosine. And remember, whatever's inside of sine has to stay there when we take the derivative, so it's cosine of y. All right, so we have y prime cosine y equals 1. Now, solve for y prime, and we get 1 over cosine of y. And now it seems like we're kind of up the creek without a paddle here, because we've got y prime, which is the thing we want, but it's only written in terms of y, not in terms of x. But our original function is arcsine of x, so we would expect that we should be able to find its derivative in terms of x alone, right? We think that that should be true. So to solve this little issue, this hurdle that we've come up against, what we have to do is remember that we defined, back up here, sine of y was equal to x. And we know that sine and cosine are very intimately related by the formula, right, this fact, sine squared theta plus cosine squared theta is equal to 1 for any theta. And so what that means for us is that sine squared of y plus cosine squared of y is equal to 1. And what we're going to do is solve for cosine y, and then we're going to replace it in our formula. All right, so subtract over, and take the square root. And you get plus or minus the square root of 1 minus sine squared y. And now the last thing we want to do, just to finish this off, right, is remember that x is sine of y. And so 1 minus sine squared y is really 1 minus x squared. Right, so what we have here is that cosine is equal to plus or minus the square root of 1 minus sine squared. Sine y is equal to x, and so we replace it there. So what we have is y prime is plus or minus 1 over the square root of 1 minus x squared. Now, that's not a great answer. Right? Why is that not a great answer? Well, we've got a plus or minus in there. But you should know what the value of the derivative is. It shouldn't be ambiguous with a plus or a minus. And so here's a little exercise for you guys. Figure out if plus or if minus is the correct choice for this.